Hi everyone, and welcome to another Arduino with Joystick tutorial. And this time we're controlling DC motors. And we have two motors and we're going to control them with this joystick. So you can accelerate forward, backwards, and even turn right and left. With DC motors, you can't directly power them off of the Arduino because they're going to draw way too much current. That's the fastest way to turn this into a lovely decorative paperweight. The best way to do it is to use a motor driver and just pick the motor driver that matches the specs of your motors. The connections are pretty easy. I have my motor 1 and my motor 2 hooked up to the screw terminals right here. Here is power and ground to power not only the motor board, which has a 5-volt regulator, but then to separately power these motors. I'm going to use the breadboard power rail for these. Then we have a series of pins next to this power terminal block. And the first yellow one right here, this is the ENA pin. And this is the speed pin for motor 1. You want to make sure to pick a PWM pin on your Arduino. Let's do pin number 5. These next two in green, this one right here is our in1 pin. And this controls one direction, and then the IN2 or the into pin controls the other direction. If we send 5 volts to this wire, then the motor will spin in a certain direction. Then sending 5 volts to the other one will spin it in the reverse direction. These don't need to go into a PWM pin. Any old digital pin will do. I'm going to put the in1 into 6, and I'm going to put in2 into 7. These are the direction pins for motor 2. So the first one, of course, is our in3 now. And because it's a direction, it does not have to go into a PWM pin. I'm going to go with number 8. And then in 4, I'm going to go with 9. So in 1, in 2 for motor 1, in 3, in 4 for motor 2. And finally, motor 2 needs some speed, right, people? So here's the ENB. This one has to go into a PWM pin. And look at number 10 right there. It is all happy. We got a happy little party group of speed. I have this female adapter I like to use for prototyping with jumper wires coming off of it. So it makes it really easy to power your prototypes. And this will hook up to a 6-volt power source because these are 6-volt motors. So never use more volts than you need to power your motors. More amps, always good, but not more volts. We have external power to power our motor driver and our motors, and it's coming in through here. And we have all of our signal wires going to the Arduino. But there's trickery afoot in the form of the common ground. Anytime that you are using external components, all your components have to share a common ground back to the Arduino. So I got this little guy here, and we're going to just loop from the ground rail to this little convenient ground pin right here. Now we're ready for the joystick. I'm going to take this ground, move these guys out of the way, and pick this ground right here. Next up is our 5-volt in red. Here's a 5-volt pin right next to our ground. Next is our VRX, and this is going to read where the joystick is along the X plane and connect to pin A0. Hopefully one of you guys is remembering all these pins. Then we have VRY, and as you can guess, this measures the values coming off the Y-axis. And we're going to want to use another analog pin for it. So I'm going to pick A1 right next to its little buddy there. And finally, the SW pin. And that stands for switch because there's a little button right there when you press down on the joystick. Now, not much use here. Perhaps we can hook up this buzzer and use it as some kind of horn. You know, like, get out the way. I'm in a rush. I'm going to put the button into pin 2 because it's a digital readout. The button's either pushed or not pushed. There's no in between, like the nuances of a joystick. For our buzzer, I'm just going to connect it to pin 13. Get its little legs in there. Before we get to the code, let's take a look at how values for joysticks work. Joysticks put out ADC values, and they go from 0 to 1023 or 1023. So if we have the joystick in the middle, if I thumb to the left, the values go towards 0. And then if I thumb to the right, they go towards 1023. And same thing for our up and down, which tells us in the middle, we should be seeing a value anywhere from 511 to 512. Of course, this is in a perfect world type of situation, which happens like not at all. For instance, for my joystick, I have an idle of about 511 for the X, but 489 for the Y. So run the code in the very first episode, and link for that is below to find what your idle is, because you are going to be using your numbers in the code rather than mine. For speed, we are going to be using PWM values, and they go from 0 to 255 or 255. So we are going to have to map 0 to 1023. That's going to be coming from the joystick from both the X and Y axes to speeds that relate to 0 to 255. Let's go to the code. We're going to go through this code step by step. But if you have any questions, feel free to post in the comments below. Or better yet, join my community for more personalized help. All right, let's get on with this. At the top of the sketch, I always like to start by setting up my pins as variables, because this makes it much easier down the line as your projects expand, and they will, trust me. So that way you don't have to go through all of your code trying to find out where a certain pin is because you moved it to another pin. Just set it up one time so you have only one area to change everything. Starting with our joystick, we have that X pin. So I called it Joy X pin, and that was connected to A0. And then we had the Y pin. Joy Y pin is connected to A1. And then finally, that switch or button, I called it button pin, and we connected it to pin 2. Then we're going to need a couple more variables to store things like what is the X value as we're moving left to right, or the Y value as we're moving up and down. Plus, has that button been pushed or not? So to store all these, I created an X value variable, a Y value one, and one for the button state. With the joystick out of the way, time for the motor. We had all those pins for either speed or direction. So starting with the first speed pin, that's the ENA pin, and I connected it to 5. Then in 1 pin to 6, in 2 pin to 7, and so on and so forth. So this is for motor 1, and this right here is for motor 2. And finally, we had our buzzer. So the buzzer pin is connected to lucky number 13. The setup section is pretty easy because all I did was just tell the Arduino what mode these pins are in. Are they in an input mode or an output mode? So for our joystick, that's all pretty much going to be input because the joystick is going to be inputting information into the Arduino. The motor, that's a different story. That's going to be output because the Arduino is going to be outputting information into our motor. How fast to go? What direction should the motors be turning? And finally, the buzzer, that's also going to be an output because the Arduino is going to be turning it on or turning it off depending on whether or not we're pushing that button. All right, time for the action in the loop function. The first thing we want to do when that Arduino fires up is figure out where the joystick is. So we're going to read those values and begin to house them into our variables. First up is the X value, and we're going to get that by analog reading that joystick X pin. And then the Y value, and we're going to do the same, analog read that Y pin. And then finally, the button state, we're going to digital read the button pin because the button is either on or off. There's no like in-between button pressage. Now we have this information. We know where the joystick is currently at. Now let's start translating this into actions for our motor. In this first scenario, I'm going to be thumbing up. That means the joystick values are going to get lower until they top off or bottom out at 0. So if the Y value is less than or equal to 485, this is all the stuff that we want to happen. Now, why 485? my Y value when the joystick is at idle is around like 489 and it fluctuates. So it's always a good idea to start a little bit lower. So I decided on 485. So the first thing we do is create a quick local variable called motor speed. And what we're going to do here is take the ADC value from the joystick as I thumb up and convert it into a motor speed. So we're going to use the map function for that. So we're going to take the Y value, and the low of the Y value is 485, which matches up here. And the high value is going to be 0. So it starts at 485 and it ends at 0. And same thing for our motor. We're going to start the motor at 70. And then when I'm thumbed all the way up, it's going to be at max speed at 255. So you may be asking, why 70? Why don't we start it at 0 and then go up? What you're going to find with your DC motors is that they don't run at all below a certain PWM value. And for these motors, 70 is a good starting point. That's when the motors start to think about turning. So you may have to try a couple different numbers here to figure out what feels comfortable for you. Now that we have a motor speed matched up to a Y coordinate ADC value, we can start making the motor do some stuff. So what we're going to do is take that motor number 1 and turn it forward. And we're going to do that by writing the in one pin high. Now, if it's going in one direction, that means the other direction pin has got to be written low. So here I do that in the very next line. A motor can't turn both directions at the same time. Now, some motor drivers, when you set both directions to high, it engages a brake feature, but not all motor drivers have that. So you want to definitely check your data sheet. Likewise, we want that second motor to turn too, or else the car is going to be all wonky. So we're going to set the in 3 pin to high. And of course, the other directions got to be set to low. So now the car is in drive. But nobody stepped on the gas pedal yet. So come on, people, pedal to the metal. So here we take the ENA pin, which is the speed pin of the first motor, and we're going to write it by the motor speed, which got fetched up here. And same thing with our ENB pin. It's going to be written with that exact same motor speed. So that way one motor is not moving faster than the other. This block of code up here should move both motors in the same direction and move your car forward. And the more you thumb up, the faster it's going to go. Next scenario is when you start thumbing down. So for here, I started the value at 495, remembering that my idle is mostly 489. So we're going to start a little bit higher. So if the Y value is greater or equal to 495, let's start moving in reverse. So first thing we do is do our motor speed conversion or mapping. So we're going to take that Y value and we're thumbing down now. So the numbers get bigger. We're going to start it at 495 and it's going to bottom out at 1023. So we're going to match that to a value of 70 and our 1023 to max reverse speed of 255. So in order to do that, well, we have to reverse the directions of the motors. So all I did was hit low on the first direction, high on the second, and then repeat it for motor number 2. And likewise, the car is in reverse, step on that gas pedal. So the ENA pin, motor 1 speed, we're going to write it by the motor speed, which was calculated up here. And same thing for that second speed pin. Next, we've hit a blockade. We got to swerve to the left. For my joystick, my average value along the x-axis was 511. Because we're thumbing to the left, the numbers are going to get smaller. So a number smaller than 511, I just picked 505. So if the x value is less than or equal to 505, we want to grab a motor speed again, and we're going to use the x value and map it from 505 to 0, because 0 is all the way left, and map it to 70 to 255. So the motor is pretty much mapped the same in every instance. In order to turn left, we're going to hold that left wheel still. So to do that, I've written both direction pins here low. The car is in essence parked or in neutral, however you want to think about it. And then as an added measure of insurance, I've also analog written the first speed pin by 0. And then we're going to move that right wheel. So I wrote the EN3 pin high to go forward and the EN4 pin low, and then only sending speed to that second speed pin. Now somebody's cut me off. I gotta turn to the right. We're going to hold that right wheel still and move the left wheel forward. So that should jerk us to the right. Moving to the right, the numbers get bigger. And so if my center is about 511, I picked 515. So if the X value is greater or equal to 515, we are going to grab our motor speed from that X value. And 515 is going to translate into a speed of 70. And 1023 is going to generate a speed of 255. So in order to turn right now, we are going to move the left wheel, which is motor 1. So our in-1 pin goes high. The other direction, therefore, must go low on that motor. And we're going to write that first speed wire by the motor speed. Then for that other wheel, we want to put it in park or neutral and write a speed of 0. It seems like we covered all of our bases. We got up, down, left, right. If the joystick is at idle, we haven't specified anything for like a segment of our dead zone. So Arduino is just going to make a choice. And that's going to cause your cart to either move or go in reverse and do whatever the heck it wants. Everything you need to know about Arduino can be found in the 1997 movie called Wishmaster. Oh yeah, you have to be so specific when you are making a wish to an evil genie. Because, oh yeah, he'll make you rich, but then he'll give you boils. And then it's the apocalypse. The same thing is with Arduino. You can see that we've made a lot of if statement wishes. So we got to tread carefully here and be real specific so this Arduino doesn't mess up our lives. So you can see that I'm creating a 10 by 10 up and down like this dead spot where the joystick can just sit there and fluctuate a little bit and it's not going to cause any funky movements. So in this dead zone, we're going to specify our 10 by 10 block where we want the motors to be still. This is one long if statement, probably could be more elegantly done, but I just went for it. So starting with our Y value, if that Y value goes above 485, but it's also below 495, that little area, and in the X zone, that X value is above 505, but below 515, we want the motors to be still. So we've written all of the direction pins low. We're going to leave it essentially parked or in neutral. Take that, evil genie. We are like professional wish makers now. But lastly, but not leastly, is our button, because if somebody gets in our way, we need to honk it and let them know. So for our joystick button, if the button state is high, that means that the button has not been pushed. Because we are using the internal pull-up of the Arduino, the button will always read high if it's not pushed, and it's going to be reading low if it's been pushed. So in this case, we're going to digital write that buzzer pin low. Shush. And in the other case, if that button state goes low, it means I am honking that horn. So we're going to turn the buzzer pin high. All right, let's get fast and furious now. So I'm going to start by thumbing up, which means both wheels should start moving forward. And there we have it. Now, if you're not too precise, then you only get the right wheel or the left wheel. So those work. And you can see that both wheels are turning in the same direction. Now, if you find that when you hit forward, one is going in one direction and the other one is going in the other direction, you can always switch the high-lows for your in pins in the code, or you can simply swap the positive and the negatives, and that'll make it spin in the opposite direction. It slows down a little bit. And then back. Finally, that buzzer. Someone has cut me off. If you have any questions about this circuit or the code, I encourage you to post below. But even better, I invite you to join my community. Every week we have live video chat events where we're either building Arduino projects every month, we are tackling code challenges, or working on member projects to help you guys keep moving your projects forward so you can build more things faster. Link for that is below. Guys, I had a blast. I'll see you next time.